Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and today we'll be exploring some fascinating developments in space exploration, from Mars sample returns to breakthrough cosmic ray discoveries. We've got an exciting lineup of stories that showcase just how dynamic and rapidly evolving our understanding of space continues to be. So let's get started. Big news from NASA about their ambitious Mars sample return mission. The space agency has just unveiled a major overhaul of their strategy to bring those precious Martian samples back to Earth. They're now considering two streamlined approaches that could significantly reduce both cost and complexity. The original plan came with a whopping price tag of up to $11 billion and wouldn't have seen samples return until 2040. But now, NASA Administrator Bill Nelson has announced they've found ways to potentially cut those costs nearly in half, with new estimates ranging between $5.8 and $7.7 billion, while potentially getting the samples back by 2035. Both new options focus on delivering the same essential hardware to Mars, a lander carrying the Mars Ascent Vehicle, or MAV. This rocket will be responsible for launching the samples currently being collected by the Perseverance rover into Mars orbit. The key difference between the two approaches lies in how they'll land this hardware on the red planet. The first option would use a scaled-up version of the tried and tested Sky Crane system that successfully landed both Curiosity and Perseverance rovers. The second approach would involve partnering with private industry for an alternative landing system. In a notable change from earlier designs, both options will now use nuclear power instead of solar panels. This switch gives the mission more operational flexibility, allowing it to work during dust storms and keep the rocket motors at their optimal temperature. NASA isn't rushing to decide between these options. They're taking until mid-2026 to make their final choice. And while China has announced their own Mars sample return mission targeting 2028, NASA emphasizes that their mission offers a more comprehensive scientific approach, collecting samples from various sites that once hosted liquid water. Next up, SpaceX is gearing up for another milestone moon launch, this time carrying Firefly Aerospace's Blue Ghost lunar lander. The mission, appropriately named Ghost Riders in the Sky, is set to lift off from Kennedy Space Center on January 15th at 1:11 a.m. Eastern Time. Blue Ghost isn't making this journey alone. It's sharing its ride to space with another lunar hopeful, the Resilience lander built by Japanese company Ispace. This team is looking for redemption after their previous attempt ended in a crash landing last April. The mission plan is quite intricate. After launch, Blue Ghost will spend 25 days orbiting Earth before firing its engines to begin its lunar journey. Once it reaches the moon, it'll spend another 16 days in lunar orbit preparing for what might be its most crucial moment: the autonomous landing attempt in Mare Crisium, or the Sea of Crises, an ancient impact basin roughly 460 miles wide. If everything goes according to plan, we should see our first high-definition images from the lunar surface within just 30 minutes of touchdown. But Blue Ghost will need to work quickly. It only has 14 days before lunar night falls and cuts off its solar power, though its batteries will give it about 5 hours to capture the dramatic lunar dusk. The lander is carrying 10 NASA experiments, including some fascinating technology demonstrations. One particularly interesting payload is Lexie, the Lunar Environment Heliospheric X-Ray Imager, which will give us an unprecedented view of Earth's magnetic field as it interacts with solar wind. Scientists are hoping to witness our planet's magnetosphere breathing, expanding and contracting in response to solar activity, something we've never been able to observe before. Should Blue Ghost succeed in its mission, it will become just the second commercial Lunar Payload Services mission to reach the lunar surface, following the historic landing of Intuitive Machines' Odysseus mission last month. Now let's turn our attention to China. In a significant development from China's space sector, the nation has launched its first batch of satellites for the ambitious Guawang Constellation project. While this marks a major step forward in China's space capabilities, the launch has raised more questions than it's answered. The initial deployment consisted of 10 satellites carried to orbit by a Long March 5B rocket from the Wenchang spaceport. A second batch is already at the launch site, ready for deployment, but details about these spacecraft remain remarkably scarce. What's particularly intriguing is the lack of basic information that's typically shared about such launches, We don't know the satellite's size, mass, or even their exact capabilities. This stands in stark contrast to China's other space internet project, the Thousand Sails constellation, which has been quite open about its satellite specifications and designs. The choice to launch just 10 satellites on China's most powerful rocket, capable of carrying up to 25,000 kilograms to low Earth orbit, has sparked speculation about their true nature. Some experts suggest these satellites might be designed for more than just internet services, possibly carrying additional payloads for reconnaissance or other purposes. The satellites are currently orbiting at an altitude similar to OneWeb's constellation, between 1,098 and 1,127 kilometers. While this might suggest a smaller constellation focused on connectivity, China's international filings indicate plans for an eventual network of 13,000 satellites. This lack of transparency becomes particularly concerning when considering the growing challenge of space traffic management. With multiple mega constellations being deployed by various nations and companies, including SpaceX's Starlink and China's own Thousand Sails project, the need for clear communication and coordination between operators becomes increasingly critical. As more launches are planned, the space community will be watching closely to see if China becomes more forthcoming about the Guawang Constellation's capabilities and intended purposes. The project's development could have significant implications, not just for global connectivity, but also for space traffic management and international space cooperation. As our presence in space continues to expand, a crucial gap in our capabilities has come to light. We're not adequately prepared for emergency rescues in orbit. Leading space experts are now calling for urgent action to address this critical oversight. The Aerospace Corporation's recent Space Safety Compendium report has highlighted what they term an in-space rescue capability gap. Currently, neither government agencies nor commercial spaceflight providers have comprehensive plans in place for rescuing crews from distressed spacecraft, whether in low Earth orbit or beyond. This issue gained particular attention during recent events with NASA's Starliner mission. When astronauts Suni Williams and Butch Wilmore's stay on the International Space Station was extended from 8 days to nearly 10 months, it highlighted the complexities of crew logistics and emergency planning in space. While NASA maintains that the astronauts were never stranded, having access to return vehicles throughout their stay, the situation required creative solutions, including temporary accommodations in a Crew Dragon spacecraft that was already assigned to other crew members. Former NASA administrators Charles Bolden, Jim Bridenstine, and Sean O'Keefe, along with other space industry leaders, are advocating for the development of international rescue capabilities. They emphasize the need for standardization in critical areas like docking systems and spacesuits. Current incompatibilities between different spacecraft systems could severely hamper rescue efforts. The experts stress that we shouldn't wait for a disaster to act. As one official noted, we shouldn't need a space equivalent of the Kursk submarine disaster to drive these changes. With the increasing number of both government and commercial crews heading to orbit, the time to develop these capabilities is now, before they're needed in an emergency. In groundbreaking research published in the Astrophysical Journal Letters, scientists have uncovered new insights into one of space's most energetic mysteries: ultra-high energy cosmic rays. These incredible particles found in extreme environments near black holes and neutron stars pack an astounding punch, carrying energy levels about 10 million times greater than particles in our most powerful particle accelerators here on Earth. For years, scientists believed these cosmic rays got their enormous energy from shock waves, like those produced when stars explode. But this new research reveals a different story. The true source appears to be magnetic turbulence, essentially highly tangled magnetic fields that twist and turn, rapidly accelerating particles to these remarkable energy levels. To put these energies in perspective, while particles from our sun reach energies of about 10 billion electron volts, these cosmic rays can achieve a mind-boggling 100 quintillion electron volts. That's like comparing a grain of rice to the weight of the world's largest passenger aircraft, an almost incomprehensible difference in scale. What's particularly fascinating is that despite the vast difference in environments, these cosmic rays share something in common with solar particles. They both get their energy from tangled magnetic fields. It's a surprising connection between phenomena occurring at vastly different scales in our universe. This discovery isn't just academic. It helps resolve long-standing questions that have puzzled both astrophysicists and particle physicists about the mechanics behind these mysterious cosmic rays. The data clearly shows that magnetic turbulence better explains the observations than the previous shock acceleration theory, representing a significant breakthrough in our understanding of these powerful cosmic phenomena. Let's get a JWST update. The James Webb Space Telescope has once again pushed the boundaries of what we thought possible, making an extraordinary discovery that's challenging our understanding of the distant universe. Thanks to a fascinating cosmic alignment, Webb has spotted 44 individual stars in a galaxy that's an incredible 6.5 billion light-years away. That's halfway across the observable universe. These stars were found in what astronomers call the Dragon, a striking tendril of light that's actually a distorted image of a distant spiral galaxy. This remarkable view is made possible by a phenomenon called gravitational lensing, where the massive Abell 370 galaxy cluster acts like a giant magnifying glass, bending and amplifying the light from galaxies behind it. What makes this discovery even more fascinating is that these aren't just any stars. They're red supergiants in their final life stages, similar to our familiar neighbor Betelgeuse in the constellation Orion. The discovery happened almost by accident when researchers were examining Webb images taken in 2022 and 2023 and noticed what appeared to be individual star points twinkling like Christmas lights. The observation was further enhanced by an incredible stroke of luck. Individual stars floating within the Abell 370 cluster temporarily lined up with the background stars, creating additional magnification. This caused the stars to appear and disappear between images, creating a spectacular cosmic light show that nobody expected to see at such vast distances. This discovery isn't just about breaking records, it's opening new windows into studying the distant universe. Before Webb, the idea of spotting individual stars at such extreme distances was considered as impossible as trying to see dust grains in moon craters through binoculars. Yet here we are pushing the boundaries of what we thought possible in astronomical observation. And that brings this episode to a close. Thanks for joining me today on another fascinating journey through the cosmos. I'm Anna, and it's been a pleasure bringing you these incredible stories from the frontiers of space exploration and astronomy. Before we wrap up, I want to remind you that you can stay connected with all the latest space and astronomy news by visiting our website at astronomydaily.io. There, you can sign up for our free daily newsletter and access our constantly updating newsfeed. You'll also find all our previous episodes available for streaming. If you enjoy our content, make sure to follow us on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. We're constantly sharing amazing space images, breaking news, and engaging with our wonderful community of space enthusiasts. Until next time, keep looking up and wondering about the mysteries of our incredible universe. This has been Astronomy Daily, and I'm Anna, signing off.